Okay, so good morning everyone. Today we'll be presenting our bioinformatics report on oxytocin. So oxytocin is a hormone composed of 9 amino acids that is produced in the hypothalamus, and it functions as a brain neurotransmitter. And the OXT gene is responsible for the formation of precursor protein, which will be processed in order to produce oxytocin. And some interesting facts about oxytocin is that it's released by the body during sexual intercourse, childbirth, and also lactation, and this helps in the reproductive functions. And in addition to that, it also helps to regulate many of the social interactions faced by humans on a daily basis, and also other social functions. And lastly, it also has a considerable impact on emotions.
The main reason for studying the oxytocin gene is to fully understand how it functions in the human body and the different ways in which it can affect humans, basically the mechanisms of effect in the human body. Synthetic oxytocin such as pitocin and syntocinon are in the pharmaceutical market right now, and they are mainly used to help speed up or induce childbirth. We hence seek to understand by doing this project the different pathways of the oxytocin gene and the difference in the oxytocin gene in Homo sapiens and other mammalian species. By understanding more about oxytocin and its mechanism of effect, it will hence allow us to understand more on the human affection and the human behavior and how this is related to oxytocin. It will also provide information that can allow for the identification of suitable hormone therapies for patients that are suffering from psychological disorders such as depression. This is because current prescription pills such as antidepressants have many side effects such as nausea, vomiting, or diarrhea, and this could actually cause physical discomfort to the patient themselves. Hence, by finding a synthetic form of oxytocin that is closely related to the real oxytocin in the human body, this can hence allow us to find suitable hormone therapies that can hence provide more physical comfort to the patients.
Okay, so moving on, we talk about the results and analysis. So the first analysis that we did was using BLAST. So by using protein BLAST and using the Homo sapien oxytocin protein sequence, we could actually identify the gene that was most closely related to the human oxytocin gene. And in this case, it's pan-troglodytes, which basically comes from the common chimpanzee. As you can see, the E-score for the pan-troglodytes is actually very low, and this indicates that it's very similar to the human oxytocin protein sequence. And the low E-value indicates that it's statistically unlikely that a false match would have occurred. So this is the most closely related protein sequence to the Homo sapien variant. So as we can see, there are 0 gaps, and the 98% match of the sequences between oxytocin in Homo sapiens and the pan-troglodytes means that the two sequences are very similar to each other. So from this, we can actually understand that the genes of the two species are very similar to one another, and they are highly identical. And there's a possibility of carrying over applications and biological interactions from one species to the other. So we could carry out studies on chimpanzees, and perhaps we could use whatever we have gathered from the studies to apply it to Homo sapiens. Additionally, we can also study the interactions of both Homo sapiens and chimpanzees in relation to oxytocin gene and have a broader perspective and understanding of the oxytocin gene.
Another way that we have decided to analyze our gene would be to look at the KEGG pathways that are involved in the oxytocin gene and comparing it to the pathways for estrogen, which is another hormone that is considered to be involved in sex and the libido. So by comparing oxytocin to estrogen, we could determine if oxytocin is also a sex hormone. Over here, we have the KAG pathway for oxytocin, and it has many branches and so on. And comparing it to estrogen, which seems to have more linear paths, we can see that it seems that oxytocin has more pathways than estrogen, and thus we can conclude that Perhaps oxytocin may be more than just a hormone that is responsible for love and other emotional feelings. Since oxytocin has many other purposes, we could study these other functions and put them to use in our medicine and further our understanding of biochemistry.
Okay, now moving on to the discussion and the conclusion of our project. It is highly possible that the mechanism of oxytocin in chimpanzees could be similar to the mechanism of oxytocin in humans as well. So we can conclude that the genetic makeup of chimpanzees could be nearly identical to humans. And also we can also identify the systems that are affected by oxytocin and understand its binding process. So by understanding its binding process, we can create this recombinant form of oxytocin that can be a form of a drug or a form of medication for people who have depression or social disorders. So this new synthetic oxytocin could be much safer and efficient as compared to antidepressants that people are taking right now. And because oxytocin will be recognized as a naturally occurring hormone instead of introducing a foreign chemical or drug into a body. So basically it's much safer and it's much better, and the human body would accept it better. So the side effects of a normal drug wouldn't be felt as much. And with that, we've come to the end of our presentation. Thank you for your time.